All right, welcome back. So on the back of the page, we are changing ideas a bit. Now, we're looking specifically at triangles and congruence with their angles and how to write a proof proving that two figures are congruent. To start off our notes, we need to know the third angles theorem. The third angles theorem says, if two angles in one triangle are congruent to two angles in another triangle, then the third pair of angles must also be congruent. Let's write that down. If two angles in one triangle are congruent to two angles in another triangle, then the third pair of angles must also be congruent. So what does that have to do with this picture right here? If two angles in one triangle are congruent to two angles in another triangle, then the third pair of angles must also be congruent. Well, let's look at these triangles ABC and EFD. Well, here in these triangles, A is marked congruent to D and B is marked congruent to E. So here we have two angles in one triangle marked congruent to two angles in one triangle marked congruent to two angles in another triangle. And so this theorem allows us to make a conclusion that the third pair, so that means C and F, must also be congruent. So angle C must be congruent to angle F based on the third angles theorem. And this all has to do with what we talked about on Tuesday about the sum of the angles in a triangle being 180 degrees. So let's apply both of those theorems, the triangle angle sum theorem and the third angles theorem, to solve problems and solve for variables, specifically y, in example 4 and example 5. For example 4, we have these two triangles, KOM and triangle RVT. No sides are marked, just two angles. Angle K is marked congruent to angle R, and angle O is marked congruent to angle M. Two pairs of angles. So the theorem that we just wrote down tells us that the third pair of angles must be congruent. So M must be congruent to T. Well, let's use what we know about the triangle angle sum theorem and what we know about what's been marked to solve for y. So if K is congruent to R and R is 45 degrees, then K must also be 45 degrees. If angle O is congruent to V, and angle O is 65 degrees, then V must also be 65 degrees. So what we know about the three angles in a triangle is that all three should add up to equal 180. So 45 plus 65 plus that y that we're looking for needs to equal 180. So if I add 45 and 65, that gets you to 110 plus y equals 180. If we subtract 110 from both sides, we find that y equals, take a second to subtract, y equals 70 degrees. For number 5, we're going to use a combination of the two theorems again. But really, mostly just triangle, angle, sum. Because in this picture, all three angles are marked congruent to each other. So starting over here with V, angle V, is marked congruent to angle R. So if angle R is 120 degrees, then angle V is 120 degrees. Then, let's go over here where the T is. Here, this angle is marked with 3 tick marks, and its measure is 20 degrees. That means the other angle marked with 3 tick marks is also 20 degrees. And these angles are marked congruent to each other. We want to solve for y. To do so, we're now going to use these 3 angles to set up an equation. Well, those are 3 angles in a triangle. That means if I add them all up, they should equal that same magic number, 180. So 120 plus 20 plus 2y plus 2 should equal 180. Adding 120 plus 20 plus 2y plus 2. And it equals 180 because those are the 3 angles in a triangle. So let's solve for y. First, we're going to combine like terms to find out that 2y plus 142 equals 180. Now, if we subtract 142 from both sides, we'll get that 2y equals what? What does 2y equal if you subtract 142 from both sides? 2y will equal 38. Divide by 2 on both sides and y equals what? 19. Now, I'm going to ask y'all what I always ask you. What could you have done right here once you got your equation? You can always use in solve. We solve for y, and now we are going to solve for x and y in this picture. Here, there's no guesswork. We're told that triangle ABC is congruent to triangle DEF. So that means all the corresponding angles and corresponding sides are congruent. Let's mark them and get started with our problem. We're going to mark the angles. So A comes first, and then on the other one, D does. So A is congruent to D. B is congruent to E. And C is congruent to F. So one simple thing that we can transfer from one triangle to the other is that if E is 42 degrees, then B is also 42 degrees. A is 87 degrees. D is 5x plus 2. Well, if they're congruent, that means that we can set them equal to each other. That means they're equal. So that means 87 equals 5x plus 2. Let's solve for x first, and then we'll come back and look at what we need to do to solve for y. To solve for x, we're going to subtract 2 on both sides and get that 85 equals 5x. Divide by 5, and what does x equal? X equals 17. Now let's look at what we've got going on in this triangle with y. We have 3y, we have 87, we have 42. We have our 3 angles thanks to E over here. And so that means that if we add up all 3 angles, that they should equal, again, 180. Let's do that. 87 plus 42 plus our third angle, which is 3y, equals 180. If I combine like terms, I have that 129 plus 3y equals 180. To solve for y, you'll need to subtract 129 on both sides, and 3y will equal 51. Divide by 3 on both sides, and y equals 17. What a coincidence. They both equal 17. So here we have a proof. It says, given that angle ABD is congruent to angle CDB, this angle right here, and angle ADB is congruent to angle CBD, this angle right here, and AD is congruent to BC, and AB is congruent to DC. Prove that the triangles are congruent. Prove that triangle ABD is congruent to triangle CBD. So most of the proof is done for us. We just need to fill in the blanks. So out of our givens, we're given 2 of the sides. They conclude that the third side, BD, is congruent to BD. Well, BD is congruent to itself. We can always say something is congruent to itself by what property? Think back to the properties that we talked about in Unit 2. Me equals me. BD is congruent to BD by the reflexive property. And then we already have 2 of our angles marked congruent. Well, by the third angle theorem, can we say that the third pair of angles are congruent? We can. What would that be? Well, that would be angle A is congruent to angle C. You don't need to write the full angle name because there's only one angle with the vertex A and only one angle with the vertex C. And so last but not least, we have the third side and the third angle. We figured out that they're congruent. So now we can say the triangles are congruent. Why? By the definition of congruent figures. All the sides were congruent and all the angles were congruent. So those triangles are congruent. Use your notes to help you complete your homework, and your homework will be due on Friday.